Okay, great. Good morning, everyone. Welcome to this LEAD webinar. I will just quickly look at these slides. So if you are joining us today, that means that you are one of the registered participants of the LEAD Massive Open Online course that focuses on unlocking city logistics with the help of digital twins. As you will recall, if you joined the kickoff webinar, we had planned a few, at least one, if needed, a few sessions that we call exchange sessions. And these are live moments where you can interact with course trainers on specific topics. And that's the reason why we're here today. So I will just start off by providing a very quick overview of where we stand in terms of the course calendar, but also some specifications in terms of course certification, if that's something that you are interested in, which might not necessarily be the case, and also some details about how you can access the LEAD platform, which will be the focus of today's session, and actually run your own simulations. This was also shared via the forum discussion in the Mobility Academy, where we have the course, but in any case, I would like to share this again in case people have not seen it. The idea then is that Joanna from Illecom and her team will give you a quick walk through the platform. So a lot of the information here that will be presented here in a way reflects what has been presented in the videos of Unit 5, which focuses on the LEAD platform, but would also be complemented with a simulation of a specific example. And the idea here is obviously for you to have the chance of asking questions. I'm sure you've had some already looking through the videos. So that's the main objective today. So we will end up with a bit moment for Q&A, a brief moment for Q&A. So in terms of the course, like I mentioned before, we are on last unit, Unit 5. All the videos have been published. So we are really nearing the end. And here you can see that the unit will run until next week. Today we have the exchange session. And then again, mentioning what I said before in terms of assignments, we will extend the last deadline. So until the 9th of June, if you haven't done so, you can complete all the assignments from 1 to 5 and achieve certification. So this is that same information. A note is all the learning materials will remain available on the platform after the course is no longer live, let's say. What happens is even new students can join at a later stage. The main difference is that then this will not be moderated. And that means that we won't actively be engaging with students. But obviously, if they reach out to us directly, we can provide extra information, as that is also in our own interest to take this content further. Then just a quick overview of the assignment. So each assignment corresponds to each unit. The first assignment, for instance, is an open-ended question that people just have to answer in the discussion forum. The second and third ones are quizzes. The fourth one is students are asked to describe a use case that they would like to test through simulate through the platform. And then assignment number 5, and that's the one related with the LEAD platform, will be published next week. And the idea is that here we will have 2. So we will have one, which is mandatory for the purposes of certification, and this one consists also of a quiz, so relatively simple. And then the second one will have to do with actually running a simulation in the platform. And for this purpose, this will be to an extent quite similar to what we will show today. Maybe the INLACOM team will provide more information on this later on. And that one will be optional, so you don't need to do that one for certification. But if you're really interested in figuring out how the platform works, I would advise you to do so, because then you will also get feedback from the team of INLACOM to figure it out. So moving on to the platform itself, the idea, well, I already kind of explained what we're going to do today, but I also wanted to mention, I know that some people have already taken advantage of these access credentials that we have provided. I'm not sure if those same people are also here today, but what we did was through the videos that are in Unit 5, you can see that there's a whole process you can follow to create your account on GitHub and then to create the credentials to join the LEAD platform. You are welcome to do that at a later stage, but for the purposes of the assignment and also of today's workshop, to simplify a little bit, we have created a series of login emails and also the password, which is the same for all. So you can enter the platform, all the models are already, the data sets are already there, and you can run your simulations and play a bit with the platform. So I just wanted to recall in case also this information got lost. So that's it from my side. I would then hand over to Joanna to start telling us a bit about the LEAD platform.
Thank you very much, Claudia, and welcome to all participants. The LEAD platform is a key output of the LEAD project, which has been introduced also through the previous modules. I trust that you have gone through all the key concepts that are behind the platform. So the idea of today's session has been to give some practical examples and explain a bit what the platform does and why we need it. So let me just share my screen. You can see the screen now, I suppose. So I have logged in here with one of the users that we have created for the scope of this workshop and the MOOC in general. To make it easier for you to have access, each user will see a different dashboard when they enter, based on what activity has been carried out already beforehand. In a nutshell, the LEAD platform has been developed as a tool to help simplify and hide the complexity for combining different models together. So a modeler in logistics can create a model, run it locally, or use an existing modeling environment to build some simulation scenarios. The key challenge in the project and for the platform has been to integrate models that have been developed from different tools and make them work together in order to simulate more complex scenarios. In the first screen, all users can see how many models they can have access to or they have created. So this is the total number of models that this user can see. The number of scenarios that have been created, the connectors and the simulations. And I will explain very briefly the key terms, which you might already have seen in the videos, but just as a quick recap here. The model library comprises different models. Here, you can see a very short description of what each model does. Each model has inputs and outputs. So we give some inputs like the number of vehicles or the number of deliveries, and we expect some kind of outcome in the format of a number or a file, a CSV file with many parameters. Similarly, you can see all the descriptions here as a generic for the different models, what these models are about. These models have been developed in the context of the LEAD for the different living labs, and some of them have been already explained in the previous units of the MOOC. Now, in order to execute more than one model, we need to build a scenario. The scenarios are used to combine different models so that the output of the first can be input to the second model and so on. We can have a bigger series of models with more than 3. And normally we use a connector so that will help connecting the two models in a way that the output is actually used as input to the second one. Now, each scenario, in order to be executed, needs to run through a simulation. I will hand over to Andreas that can explain the whole process through a specific example. What I wanted to explain a bit here is this data assets area. We have uploaded, for the reasons of this workshop, specific, sorry, 1 second, because assets, meaning data sets, input parameters to the models and the simulations that can be used directly for you to get acquainted with the platform. This is not the only data sets that can be used. This is just for the reasons of our example here today, and for the unit 5 test that you want to run. The idea here is to have pre-uploaded data sets that can be used in the simulations and the models as inputs, but the platform allows for you to develop new data sets, upload them and use them with the different models and play with the different parameters, which is also what this is all about, so that you can tweak some parameters and see how this affects your model and how does it affect the simulation results. So I will hand over to Andreas, who is the master behind building the platform, to explain more. Thank you.
Okay, thank you, Anna. Okay, let me also share the screen. Okay, so normally you should be able to see my screen right now. Is that correct?
Yes,
Yes.
we can see
Okay,
it.
so I would like to mention also that as data assets, this was a limitation. We contacted the partners, and of course, using data assets, sharing data assets is a little bit of a sensitive issue. But normally, you can see that, of course, in the platform there are data assets that correspond to each living lab and each model. But of course, it's not possible to share everything. For the context of the MOOC session, we have prepared these data assets, which are the ones that we are going to use. As Ioanna said, there are several scenarios. A scenario is practically a way of combining, let's say, two models. For example, here I take the Echelon version 1. Maybe I take also the Coppert, and Coppert calculates, for example, the emissions of internal combustion engines, and then I can connect them, and then the platform will realize whether there is a connector available for such a connection of models, and provide the model. I can give them this scenario name and I can save it, but of course this sequence is already created here. For this context, we have prepared for you some data in order to run the scenario using the Echelon V1 CSV and the Echelon and the EVCO2. So we are talking about the Echelon. I will briefly explain also. The echelon will calculate the total distance traveled by cars and the total time needed, the number of cars needed for to execute some deliveries. And given that these deliveries will be done with the usage of electric vehicles, then the EVCO2 will calculate the environmental footprint of such activity. So going into the scenario, we can run a simulation, give the simulation a name, okay, and a description optionally. And then we will be redirected to the simulation wizard. This simulation wizard has 4 steps, as you can see here. First, we define the parameters for the echelon version 1. Then we define the parameters of the connector model that connects the echelon version 1 to the EVCO2, and then we'll give the EVCO2. Now, as I said before, there are assets that we have pre-configured for ease of use, but of course one can actually upload, for example, data. I have the same data here available, but you could as well upload a file from your own PC. So here, for example, for the first one, I uploaded it. And while for the second one, let's say that I will take it from the assets. Now, can we, I mean, we could take a look as well to understand, let's say, what these files are all about. So in terms of facilities that we are going to use a file here, that could be, for example, a name of the facility. This is a comma separated file, a semicolon separated file. So basically we give some metadata like names and location, postal codes. Then one of the major things is the location of the facility and the operation hours. And then there are some other parameters as well of the model. But basically here you can see that all the parameters of echelon are CSV files. So they are also very easily configurable, and someone could change them and restart a new simulation based on new parameters. So let's also give an area file and a vehicles file. So for this demo, I have prepared 2 different vehicle types, one for heavy duty trucks and one for light commercial vehicles. Let's use the heavy duty trucks now. Now the connector needs information on the vehicle itself so as to pass it to the EVCO2. In this case, for the heavy duty trucks, it's nothing more than the vehicle consumption in kilowatt hours per 100 kilometers. So a JSON for this input can be seen here. As I said, since we use the heavy CSV file for echelon, we will use the heavy JSON file for the connector. And then we pass to the configuration of the EVCO2. Normally, the EVCO2 takes 2 files, 2 Excel files as parameters. One consists of the factors. So the factors file determines the source of the electricity generation. So how did this electricity was generated? If it was generated by coal factory, you understand that the environmental impact of such electricity generation is much heavier than other methods like renewable. So for each percentage of the electricity, and I will share this some demo of this file as well. So for example, you can see that there is a generation percentage. So we can see that in this demo data that we have a 2.4, for example, % of electricity generated by coal. And you can see that the emissions factor for this kind of generation is quite high. different to other factors. So I am also using these factors. Now, as I said, the EVCO2 actually accepts another input as well, which corresponds to the vehicle's consumption. But this is now calculated, generated, and provided by the connector. So you can see that the platform will deduct such information and will not give you an input for this file. If someone wants to run actually the EVCO2 standalone, you can see that the consumption file is also provided. Afterwards, finally, we can review the simulation and start. Now, as we wait for the simulation to finish, here there is a status indication. You can see that we have already run 3 demo simulations with this user, so that we have a heavy-duty trucks case, a light commercial vehicle case, and we ran also the simulation with different location of the facility. And we could actually, go into the menu and see the results of the simulation. And here you can see, for example, that you used the inputs that you used. You can actually download as well the results into a zip file, and then we could as well see the emissions, the actual raw input of the models. But this can also be seen in some graphs depending on how the models are set. Now, even better, one can actually choose, okay, this simulation, you can see that the simulation is also done. One can choose all the simulations, define a baseline simulation. Let's now use this one and review the results together. And this could actually provide some insight, business insight on changing, for example, the location of the facility. As I said before, this demo V3 was using a different facility location. This one should be the same with the first one, to be honest. And you can directly see and compare the results of the simulations. Download report as well. This data, this output can also be downloaded as a PDF in case someone wants to share it like that. And I think that I can stop here and give the place to questions and maybe something more that some feedback. Thank you.
Thank you for that, Andreas. I open then the floor for questions. In the Q&A, there is one. So the question is there a documentation to understand how the models work? For example, each model includes data, variables that are part of a formula. I would like to understand how those variables, same for information about the scenarios.
So yes, okay. So inside the models, one can go and select, the model in question. Let's say the Echelon V1 CSV that we used before, and then you can see that there is a generic, there is some description, there is, the version, and then you have also the GitHub URL of the model. So whatever the modeler actually provided in the GitHub directory can be accessed there. Most models, at least the vast majority of the models, should be public, and I can check this, but this is the actual location of the code and documentation of the models. Now, inside the platform, though, we have also provided, let's say, some documentation that the config CSV, configuration of the execution. So it's not always clear, you know, what the Echelon model needs, but in the GitHub repository should be defined from the README that the modeler created.
So from the GitHub, from the link here, one can download the model and the documentation of the model itself.
Yep, that's so I just want to see that, yes, that the model is public as well. Now for you can see that there are multiple branches. So in the case of lead, usually I have created a lead packaging branch for all the models available. And then there are much more information inside here, you can see. You know, even the output, usage, if someone, this specific, an interesting point, actually, I would like to say that as we said, this model sequence through the platform allows us to run any kind of models, no matter the technology. So if one is a Python model, the other is a R model, it doesn't matter. For the platform, the containerization, there is a process that has been done for the integration of the model, and someone can run it as is. But you can see that I have put here information for building, running, and also even example executions.
Thank you, Andreas. I hope that answered your question, Luciano. If it hasn't, just raise your hand or just follow up. I see also a raise hand from Daniel, so I will allow you to speak if you wish. You can unmute yourself and ask your question directly. Let me see.
Daniel, you are muted. I'm just repeating Claudia, sorry, maybe.
Well, in the meantime, we have another question while Daniel perhaps figures this out. So someone asks, what is the best way to use this to test different business models?
So what do you mean with business models? In terms of the platform, I understand we are running models that code that someone created and serve a business scenario, serve a business target. So for example, in the example that I presented before, as a business outcome, it could be the location, you know, the optimization of the location of the UCC, of the facility, of the consolidation center. So through these models, one can deduct business targets, business insights. Business model, since in the lead platform, as a model, we consider the actual code, you know, that runs in order to quantify something. I would, let's say, separate the terminology, use model for the code, and as a business insight or a business scenario would be the output provided by the model.
Just to add here, a business model can, part of the business model will be to decide, to support decision-making on locations, on the number of stops, the number of vehicles to be used. So the idea here is to, you can change the different parameters based on the specific models that exist at the moment, or use your own models. And by changing these parameters, you can see how this impacts its decision. And in that way, you can decide if you want a hub at some place, if you need 2 mini hubs, So you can play with different what-if operational scenarios, and this support decision making. It's not straightforward. It needs some preliminary work to define which are the parameters, but at the end of the day, you have a tool to support some of the decisions with concrete results of the simulations. It's much easier to simulate a number of what-ifs than to try them out in the real world. So this is the key benefit.
Dimitris, perhaps you want to complement that?
Not actually, because Andreas and Joanna have totally covered what I wanted to mention, so it's okay.
Okay, great. I'll go to a different question. So can you do simulations of passenger mobility too on the platform, or is it strictly connected to logistics?
When it comes the design of this platform in its core has been to be able to run any model based on a specification, okay? But the fact that all these models, as I said, there are Java models, there are Python models, Matsim, MassGT, there are a lot of technologies that have been used in the platform, and we managed to do this how? Because every model is containerized. So basically the platform has defined the specification for inputs and outputs, and then it passes those inputs and outputs to the container. So I'm not sure if anyone knows about Docker and containerization in general, but the fact that we are using containerization as a means to run the simulations results in being able and being flexible on running any model that has been containerized based on our specification. So yes, the answer is yes. This could be applied in different areas as well.
Yes, the answer is that at the moment because these models have been developed for last mile logistics specifically, there are no existing models that can cover passengers mobility, but the platform and its functionality can support those kind of models as well.
And can I add something? This is quite a bit more advanced, but I would like to mention that if someone has a container uploaded in a public repository, so I'm still sharing my screen, perfect. So you can see that inside the models, one key parameter of the model is the Docker image. So you provide a registry, this is how it's called, but now I'm getting too technical, I believe, and I don't want to. What I mean is that if someone uploads a container and inputs all these metadata to the platform will still pull this container from this public registry and run it, no matter the nature, let's say, of the model itself. So it is quite flexible and quite open, actually.
Yeah, thanks, Andreas. I think something relevant that is also really our goal is to mention again that the platform is, an open access one, and the idea is also that current users and future users can indeed upload their models, upload their data, and run different simulations considering different scenarios, because obviously we have the use cases of the lead living labs, but those are very few within the world of logistics and beyond. So thank you for this question. We have a couple of more. So the next one is it possible to visualize VRP routes to map?
No, it's a feature. It's a feature that we will no. Currently, no. It's a feature that we actually want to, and we have it on our plans. Currently, no.
Yeah, indeed, from the get-go of the project, I think that's one of the questions that we got the most, whether there would be a visualization feature, but perhaps in the future, let's hope so. We have a few more questions. So the next one is, if we have data, for example, longitudes and latitudes, how can we add it in data assets?
Yes, yes. I mean, I can also show you that here, for example, the way that I created this data asset is simple, demo. I'm still sharing my screen, so create asset, and then you can see that below, let's say, the hierarchy of the asset, one can add several data assets. So this is an XLSX file, for example. Let's say create, upload, and then upload it from your machine. It's that simple. Update it, and yeah, I mean, this is an Excel file. And you wait a little bit, and now you have the asset data actually available in the platform. It is that simple. That said, one can directly, as we saw before, in the simulation wizard, you can upload the data there too. But if it is, let's say, a large amount of data, you know, it's hundreds of megabytes, and you are going to use it again and again, then of course it makes sense to upload it as a data asset, and maybe use you know, the simulation wizard for smaller, easily modifiable, let's say, data.
Okay, great. And we have yet another question. So I guess the question is if it is possible to find any model or models to test the economic outcome of collaboration, specifically resource sharing, and environmental impacts and others.
So I will answer on one part because I am not sure about the other. Maybe Dimitris can answer. But in terms of the environmental impact, in the platform currently we have a Copert. So Copert, you can also search for it, is a European standard for the calculation of internal combustion engines. It takes an input as an Excel file, and then it runs the model and calculates the emissions. And then we have the EVCO2. So these are the models that have been developed in the context of LEED by partners, other partners, and I was also involved in the integration of these models. So the environmental impact part is this. The first one, I'm not sure I can answer, but could you please repeat, and maybe Dimitris can also bring some more insight?
Yes, I can handle the second part. So regarding environmental impacts, there has been Copert, which is a closed source but open to be reused model. So it has been integrated in the platform, like Andrea said. We also had models developed within LEED for EV or electric delivery vehicle emissions calculations, such as EVCO2. You can see it listed here as well. This is specifically to environmental impacts. Now, on the collaboration and resource sharing part, it was this aspect has not been in the main focus of the models inside LEED. So there has been no model that specifically, focused on this. The models were more focused on, estimating fleet sizing, comparing one echelon with two echelon networks, crowd shipping, and other parts. But collaboration is definitely a topic that a lot of models would like to focus in the future. So.
Thank you, Andreas and Dimitris. Then another question going back to Copert. So when we use Copert, we have to use the country, temperature, humidity. Which information do you use in an example?
Okay. Let me. So I'm not sure about the question, from which perspective I should answer Copert demo. So I will just Copert demo. I will just start a simulation for Copert, and you can use you can see that based on the metadata of Copert, one provides the Excel file. I will go deeper into that in a moment. And then there are a few more Boolean parameters here, like keep, no evaporation, EF, EB. So one that knows about Coppert and logistics. Honestly, I'm not sure about EF and EB. From I was from the platform side, so and country, alternative country here, for example, for Spain, it would be something like ES and so on. Now, in terms of the Excel file, I would ask you for a moment to find, the executions of Coppert and sample data input, and an example input of Coppert is this one. Oh, let me also zoom in a bit. So you can see that the input of Coppert has several, it's an Excel file with several sheets. And then we are in every sheet, there is, this year and number kind of pattern. These columns here are always the same and correspond to the vehicles used. But then you have the number of vehicles used in the stock, the activity of the vehicles, in terms of kilometers. And I will not go through everything. It's peak speed, urban peak speed, off-urban peak speed, share as well, temperatures, as you mentioned, for example, min, max, and humidity. So given that you create this this Excel file and you provide it to the model here, from either from a data asset that I haven't actually shared a data asset for Coppert, or from your own machine, you can then go next and run the simulation. I hope you mentioned, part of the columns of the Excel file. I hope that I gave the full picture now.
Thank you. I'll ask Alicia to, if that hasn't been fully answered, to just follow up. And then another question is, how can we create the prediction of errors or demand for the next years, for example?
How
can we create the prediction of errors or demand for the next years?
With a model that then will be integrated in the platform. The platform will not you need to make a model for it.
Yeah, may I step in here? Assuming that you mean parcel delivery demand, right, in this question, there has not been, as Andrea said, a specific model, for example, a forecasting model that, predicts demand. It has not been in the focus of the Living Labs. The Living Labs focused on other very complex issues. For example, such as demand synthesis based on, existing demographic data, etc., and other parameters. Very state-of-the-art models, for example, in the Lyon Living Lab, which estimate the demand based on other parameters, but not like this typical artificial intelligence forecasting methods. So as Andrea said, this could be a model that can be developed in the future and be integrated in the platform to work with other models under scenarios.
And I hope you could see that basically what Dimitris was saying. I also highlighted here that there are actually, but this is not predictive. It's using actual demographic data in order to create a synthetic population, which is going to be used in the subsequent models. But yeah, there are other models, but not this one.
Thank you. There's another question. Let me see. I think it means that if the demo data sets contain real data, and if these can be used to calculate a certain output. That's how I understand this question.
The demo dataset that has been provided in the context of this MOOC are subsets and randomized data, for example, that I was confirmed that I can share with you. So this is, I will take a different twist in this question because, okay, and basically you saw the outputs. So the outputs were the total distance covered by the fleet that we gave as input, the total time needed to serve the deliveries, and so on. The CO2 grams. So this was a environmental impact output as well. But I would like to say that yes, there is the different twist that I would like to answer here is that yes, it's clear that for these models, for every model actually, there is a hard, let's say, dependency on the input data. And this is true for all the models. And I'm sure that if I could congratulate you as well, and if you create some model and so on, it would be nice to use standardized formats first, for example, but it's not always the case. Companies give data in some Excel format, their own specific use. So models use this, proprietary, let's say, format.
Yeah, which brings us back to the not yet answered question of how to get data to run simulations. And within LEAD, we did have a lot of public-private cooperation. So obviously that facilitated that project, but on, without the scope of a EU project to cooperate on and considering, competitive advantage and so on and so forth, we all know that at times for some logistic companies may be a bit, I don't want to say suspicious, but not fully willing to share their data.
Actual data, yes.
So at this moment, I do not see any additional questions. I would ask the participants if you still have any to write them on the chat or on the Q&A box. Otherwise, if that is not the case, we will be closing this webinar. For now, I hope it has been useful. It is a complex topic. Thank you to Andreas, Joanna, and Dimitris for walking us through it and for answering all the questions. Obviously, we will be available for any follow-up after the webinar and after the MOOC as well. So, when you're playing with the platform, if you have specific questions that pop up, we will be glad to follow up. I do see a hand raised, so let me see. Joseph, you should be able to talk now. Let me see.
In any case, you can add your questions in the discussions forum as well, and we will try to create an FAQ based on the questions raised today and any others, so that we can have consolidated answers for the whole team.
Yeah. Joseph, I see that you're unmuted. Would you like to pose a question?
Yeah, thank you very much for your presentation about this model. I'm calling from Tanzania. My question is about the Echelon technology. How can it be used to assist us in low developing countries?
How it can be used to assist?
Us, this technology in low developing countries in managing the last mile logistics.
Okay, so the Echelon specifically, which was one of the first models that we integrated in the platform as well, will take a file, an input file of the deliveries to be served. And then based on this, the outputs, and we saw as well, would be the numbers of vehicles needed in order to serve these deliveries, the total time needed, and the total distance. So one advantage of the Echelon is that it uses math. It's not doing any routing, for example. So it uses math, and that's why it's really fast in order to calculate, to estimate approximately the needs. But I would see value on this, no matter the developing or not countries. You have an estimation based on the deliveries. I would assume, let's say, that some operator could run this model every day on a set of deliveries to be served, and then he could have an estimation of the fleet necessary and the activity of the fleet. So,
And what about the cost for the system, the whole system?
So the cost, it's a very good question. The cost, this could be deducted. It's not included in the model, okay? But this is a very good idea for a model, actually, because, different countries have different costs for fuel, for example. So the Echelon specifically will give you the total distance. But if you plug a model in the sequence of the Echelon with information on the cost per kilometer for example, using the car and the operational costs, then, for example, this could be also an output of a subsequent model. It's not an output of the Echelon, though.
For instance, in Tanzania, 1 liter of petrol fuel is almost $1. And it can, most of the car can travel about 6 kilometers. Can you please use the dimension and see if the Echelon system can work?
I mean, given these inputs that you provided, the consumption of the vehicle and the cost of the fuel, I can see that it's quite easy to also calculate the cost. All I'm saying is that this is not provided by the Echelon, though. The Echelon will give you the total distance that will be covered based on a set of deliveries. So the cost is something to be calculated on those outputs.
Okay, thank you.
You're welcome.
Thank you, Joseph. There's one more question. I'm not sure I understand this. It's for whom this information may be useful. I'm guessing by this information, it means who would be the people that could benefit from the usage of the LEAP platform. That's how I interpret this question.
So I would see two. I mean, I will answer, Ioana, but please follow up if you want. But I can see two major actors here. For example, the courier operators. So the ones that need to perform the deliveries, define their fleet every day, understand their costs and their activity, let's say, not costs because of the previous question, understand their fleet activity. And from the other side, you have the environmental impact. So in the context of LEAD, there are a lot of models. We have also a noise model, for example. So the impact of noise pollution. So we have internal combustion engine pollution, electric vehicles pollution, and noise pollution. So this could be actually very useful for municipalities, let's say. Obviously, I might be missing a big part of other actors that could be interested in such a thing, but this is from the top of my head. Ioana, Dimitris, if you...
Just to add scientists in the area of logistics, mobility, and so on. So we have key users from the city perspective and from operations. It's not only the couriers, but other like hub operators, transport operators,
Through the facilities,
operators,
the facilities.
LSPs and so on. So people in the field, people in the cities, and scientists. These are the key categories. Now, because the platform has been designed to be open, it can support other areas. So the key models here focus on last mile logistics operations, but as we explained, it has been built in a way that can support mobility, passengers mobility, long distance transport, and other kind of models for similar categories of users.
Indeed, and the person who asked the question agrees by saying that they think that the platform can be useful for researchers as well. One more question, and after this, I suggest we close it as we're hitting the 1 hour mark. How can we add the API to the model in the platform?
How can they?
Add the API to the model in the platform.
So this, if I'm not mistaken, I don't think it was, if you want me to do a demo of that, I can do it. It's not a problem. I think, Joanna, it was not the context
a
of this
video.
presentation. We have a video for the model creation, okay? As I said before, you know, I am in the models menu and I create a new model. I can give a name, I can give a version, and after the creation of the model, then we have also the model inputs and outputs. So through this, there is a, you know, a wizard for integrating a model. What I would like to say though, that, you know, the model itself needs to be as well created in a very dynamic fashion. And this was quite a bit of the effort in the context of the development of the LEED platform, because, for example, if the model uses a directory, I will say it now plainly, if it uses a directory, you cannot have inside the code of the model your directory of your own computer, for example. So there are not limitations, there are specifications to be followed in developing the model. And then there are specifications to be followed in packaging the model as a container. So here you need to provide, for example, a registry, a container registry where the model exists. Now, with the modelers in LEED, we have been through this process quite a bit, and there was a very well, you know, a good exchange of information on that. But it is a bit more involved for the context of the question. That said, definitely, if you are aware of Artifact Hub, for example, where there are a lot of open models, Artifact Hub, oh, not GitHub, but okay, it's a little bit more complicated. I just want to see in terms of the doc. So yes, I'm in the process of updating a bit the documentation in the GitHub LEED platform documentation page. So maybe a bit of this part will be added here.
And I think, may I step in to say that if you have any type of model that you think that would be interesting to be integrated in the platform, reach out to us at Inlecom, and we can see if we can support you with this process. This will also be interesting for us.
Definitely. Thank you, everyone. Thank you to the speakers. Thank you to the participants for posing a lot of questions. We remain available to follow up after this webinar, and yeah, look forward to exchange with you in the future. Thank you, everyone.
Thank you, Claudia, for moderating. Bye.